we are going to find the domain of rational expressions. Remember, when we defined the rational expression, we mentioned that the domain was everything that stops the denominator, or that doesn't make the denominator 0. So it's kind of weird to list it as what it can't be, but that tends to be the easiest case. So, for example, suppose we have x minus 2 over x squared minus 2x minus 8. Well, just like before, what we care about is this piece right here. This can't be 0. So we're going to take just the denominator, and we're going to write x squared minus 2x minus 8 cannot equal 0. Now it behaves just like an equal sign, except that it's ruling things out rather than leaving things in. And so as a part of this, we are going to factors of minus 8 that add up to minus 2 are minus 4 and plus 2. We say those can't be equal to 0. So it says x can't be equal to 4 and x can't be equal to minus 2. So in set builder notation, all values of x such that x does not equal 4 or x does not equal minus 2. This says to include anything that isn't a 4 or a minus 2. The other thing that we could do is we could do this in interval notation. This allows for everything from minus infinity to the smaller of the two numbers, from that smaller number to the next smaller number, and from that number to infinity, since there's only 2. Notice this says everything up to 2, up to minus 2, everything from minus 2 to 4, and everything from 4 to infinity. So I've now got my domain in one of these two ways. A lot of times I'll just write it like this because I'm not answering a question with it, but I am still using it. As another example, suppose that we have our earlier one, which is going to look like the last one, but suppose I have an x squared plus 2x minus 8. Well, again, we take the denominator, we say x squared plus 2x minus 8 can't be 0. This factors as x plus 4 and x minus 2. So x can't be minus 4 and x can't be 2. Now notice that changes our interval notation answer. Specifically, the order is now different than it was before. And as well, if we go back to the original, this gives us x minus 2, x plus 4, x minus 2 on bottom. Notice that these divide out, but this is really, really, really important. When I rewrite this answer, the domain is still that. Even though the x minus 2 divided out, the 2 cannot be a part of this, otherwise it's not the exact same as this. Because the idea is that anything I plug in here will be the same thing I get if I plug in here, and if I plug a 2 in, I will get 1/6, and here I'll get 0 over 0, which is undefined. And 1/6 does not equal an undefined number. It's very defined. So once it's in your domain, it's always in your domain. But the idea is factor the denominator, set it not equal to 0, solve it like it was an equal sign, and that will give you the numbers that are not in your domain.